In this exercise, we are going to optimize our bubble sort algorithm. For now, we are declaring and initializing some arrays with 5 or 6 values inside it. But imagine what would happen if we had an array with 1 million indexes. What do you think if I have only one swap to do on my array and I will loop through it 1 million times? No, there's no way we are going to do this. And this is the purpose of this exercise, is to optimize our sort algorithm. In other words, we shouldn't loop on the array when the array is sorted. All right, so we are supposed to loop through it until the array is sorted. When it is sorted, we can stop looping through it. Okay, it has no sense, there's no point keeping looping on a sorted array. So I'm going to execute this small program, and as you can see, I'm having an output saying we went through the array one time. So yeah, there is an S because basically we wanted to count the number of times we went through it. Anyway, but if I'm doing this 5, so in this exercise, in this example, I'm doing the worst case we could have. And the worst case we could have, as you remember, is the biggest number on the left and the smallest on the right. All right, so 5, 4, 3, 2, 1. It is the worst. And as you remember also, in the worst case, I will loop through the array, the size of the array minus 1. So my array in this case is 1, 2, 3, 4, 5 indexes. So the size is 5 minus 1, 4. So we want to have the number of times we went through the array, but we want our algorithm to stop the program immediately, to stop looping through the array when we find that the array is sorted. Let's do another example. This time I'm doing 1, 2, 3, 5, 4. So then I have only one swap to do here, 1, 2, 3, and I'm going to swap 4 with 5. So let's see how many times we are going to loop through the array. We are looping 2 times because the first time we are swapping, and the second time we are checking, I would say, the array is sorted. So the goal of this exercise is to sort the array, but to stop when the array is sorted. So if I have no swap to do, I should go through it only one time. At the maximum, in the worst case, I should loop through it 4 times. All right? So I'm waiting for you for a solution. Okay, so to summarize, the difference between the last exercises in this one is, in the last exercises, we were not stopping the algorithm to loop, even if our array was sorted. As I told you, imagine my array has only one swap to do. In this case, in the last algorithm we did together, we were looping 6 times on the array, and it is pretty much useless. So we want to stop when we detect the array is sorted. Let's jump into it. I'm using length method one more time to have my array length. I'm declaring a variable named count to obviously count the number of times I went through the array, and the boolean, a variable of type boolean called swap. I'm entering the outer loop, and immediately you see I'm setting it with the length of my array. Okay, -1, because as you know now, there is no need to loop 6 times, 5 times on this one, because the rule is the length -1 in the worst case. So I smaller than length -1. As I'm entering the first time, I'm going to loop through the array the first time. I'm immediately initializing my swap boolean, my swap variable, to false. Okay? And I'm starting the inner loop to move from the left to the right in my array, using the same thing I did in the last lecture. So I'm using j smaller than length -1 minus I, because as you know now, there is no need to go to the extreme right of the array, and the more we are going to loop inside it, the less we will need to go on the right. So I'm removing I, as I will become bigger and bigger. So I'm doing the usual algorithm, checking if my array j is bigger than my array j plus 1. Okay, nothing new here. So I'm checking those two values. And if these conditions return true, this means we need to do a swap. I'm swapping the values, and as we entered this if, I want my boolean to be set to true. I'm going to go outside my if, and I'm going outside also of my inner loop. I'm using the iterator operator to increase the value of count, because obviously I went through the array one time. So I need to get this information to know, to start counting the number of times I went through it. So, and I'm entering an if not swap, I will break. So let's take a deep breath before I'm going to explain you what's going on here. If swap is true, which is the case now, this operator will return the reverse. So in this case, it will be the reverse of true, so false. So I will not execute what is after the if. So I will not do the break. But when my algorithm will not detect any swap, my swap variable, my boolean, will remain to false. So the time where I'm not going to touch the value of swap it's going to remain false, and when I will hit this if, it will mean the reverse of false, which is true, so I will break. In other words, when we will not find any swap, we will break and go outside this loop, the biggest loop, the outer loop. All right? This means when I will arrive at the end of my array without the information, or I would say with the information I didn't do any swap, I know it is time to break the loop and stop looping through the array. All right, so one more time, what happened in this algorithm is I'm looping on my array. I wanted to do it 5 times, but I'm using the swap variable, which is a boolean, to have the information if on a loop, on an iteration, I swapped something. So at the beginning of the inner loop, I'm making sure my swap is false, is containing false, and at the end of this loop, of the inner loop, I'm checking the value of swap. So I'm checking the information. If swap remains to false, I know this is time to break my outer loop, so to stop the program, so to stop the bubble sort algorithm. Indeed, of course, if I'm collecting a true, I will keep looping on my array, okay? And at the end, I'm doing an output providing us the number of times we went through the array. All right? So I hope you're comfortable with this, and I will catch you in the next lecture.